Welcome back, everyone. Today we're going to do section 8.6 on tables and other integration techniques. So in your book, if you have the 9th edition, it's on page A21 to A24. If you look in your appendix, if you have a different edition, you'll find a similar list of formulas. The ones that I want you to have on a quiz or a test, I'll provide that on the quiz or test. So the basic idea is we're given these integrals and we're basically just trying to make them look as much as possible like one of the formulas in the table. So this one is closest to number 13, which says that the integral of 1 du over u squared times a plus bu squared ends up as negative 1 over a squared times a plus 2bu over u by a plus bu plus 2b over a times natural log of u over a plus bu and all that fun stuff plus c on the end there. So this one already kind of looks how it's supposed to. We just have the 6 and 5 in the way. We'll just do 6/5 integral of 1 dx over x squared by 5x minus 3 quantity squared. So here our u is just an x, our a is a negative 3, and our b here is a 5. If it helps you to see that bottom as negative 3 plus 5x, go ahead and switch it to that way as well. So after that, really I'm just following the recipe. So we have negative 1 over a squared. A squared would be 9 times a plus 2bu, negative 3 plus 2 times 5 times u is x, over u, again x, a plus bu, negative 3 plus 5x, plus 2b, 2 by 5, over a, negative 3. Natural log absolute value of u is x, a plus bu, negative 3 plus 5x again. Close it all up, plus c, and then just a little bit of cleanup work. So this would be we have our 6/5 of this whole mess. So positive by a negative is a negative, and the 6/5 by 9 will reduce to 2/15. So negative 2/15 of a little cleanup inside, negative 3 plus 10x over x by negative 3 plus 5x. Minus 10/3, natural log absolute value of x over negative 3 plus 5x. Close it on up and add c. And that's as far as we go on our first one. Our second one, we're looking at integral of x dx over square root of 16 minus x to the 4th. So closest is number 41, which says integral of 1 du over square root of a squared minus u squared is worth arc sine of u over a plus c. So here our a is a 4, our u is x squared, du then is 2x times dx. So I see an x dx, I don't see a 2 there, so we'll multiply by 1 using a 2 inside and a 1/2 outside. So now we have 1/2 integral of du over square root of a squared minus u squared. So then that's 1/2 arc sine of u over a plus c. And then we just sub in the original. So 1/2 arc sine of u is x squared over a is 4. And we hold on to our plus c. All right. So next one, a little bit more brain exercise. But the same idea. Try to make it look like something that we already know. So in this one, we get to play with the integral of cosine to the 4th of 5x times dx. Our closest candidate on this would be number 51, which says that the integral of cosine to the n of u du is cosine to the n minus 1 power of u sine of u over n plus n minus 1 over n, and it gives us another integral of cosine to the n minus 2 of u du. So here our u is 5x, so du is 5 dx. I see a dx, I don't see a 5. Again, we just use our trick of multiplying by 1. So we're going to be bringing a 1/5 along for the ride in this guy. So then this is 1/5 integral of cosine to the 4th of u du. So then that would be 1/5 of, and then just following the recipe, cosine to the n minus 1. So here n is 4 at the start. So that would be n minus 1 would be 3. So cosine cubed of u sine of u over n over 4. Plus n minus 1 over n, 4 minus 1, 3 over n of 4. Cosine the n minus 2, so cosine squared u du. Close that on up. All right, so we'll do a little bit of distributing here. So we have cosine cubed u sine u over 4 plus 3/20 integral of sine squared u du. Now, my apologies, cosine squared. Cosine squared u du. I don't know where that sign came from. At that point, once you're down to a cosine squared, you're just using power reducing formula from there. So you have cosine cubed u sine u over 4 plus 3/20 integral of, so remember cosine squared turns into half plus cosine of 2u over 2 times du. So that we can kind of split up a little. So you have cosine cubed u sine u over 4. So then plus 3/40 integral of du. If you want to keep the 1 in there, you can. So I just factored the half out. And then plus 3/40 integral cosine of 2u times du. Cosine cubed u sine u over 4 plus 3/40 u plus 3/40 antiderivative of cosine would involve sine, so sine of 2u. I don't see a 2 out there, so we'll need a 1/2. And finally plus C. Little cleanup there, and then we're just ready to plug our original u's back in. So cosine cubed of 5x, sine of 5x, all over 4, plus 3 times u is 5x over 40, plus 3/80, so multiplying the 3/40 on the half, sine of, careful here, 2u 2 times 5x 10x, plus c. And then the only thing we would do to reduce that, go ahead and turn that into a 3/8. Typically I would take one more line to do that. I, however, have written myself out of space. My apologies, I distributed it most places. I distributed it here, not here. 20s. So 20th, cosine cubed 5x, sine 5x, plus 3x over 8, plus 3/80 sine of 10x, plus an arbitrary constant. So again, some of them pretty fast, some of them a little on the time-consuming side. But we're just trying to find one that looks sort of familiar and put it to work for us. All right, so next up, another fun with trig integral. So we're doing integral of sine theta over 23 minus 20 cosine theta times d theta. So this one, a little bit less work than maybe the last one. So here, the u substitution is a little bit quicker. U would just be 23 minus 20 cosine theta. So du is 20 sine theta times d theta. So I see the sine theta d theta, I don't see the 20, so we're multiplying by 1 again. Bring your 20, bring your 1/20th. So this would be 1/20th integral of 20 sine theta d theta is du. 23 minus 20 cosine theta is u. So this is 1/20th natural log absolute value of u plus c. So 1/20th natural log of 23 minus 20 cosine theta plus c. So some of them are shorter, some of them are a little longer. It just varies problem to problem. So let's see, so this was 8.6. 1 to 49, the odds. Just a little, not hint, but correction on number 7. Number 7, the book answer is incorrect. Let me go ahead and find that, your final answer. You know what, if you get stuck on number 7, we can go over it in class. But I don't want to spoil it for those of you that look at the answer at the very end of the problem. All right, so any questions, get in touch with me. Otherwise, I'll see you next time. Stay safe out there.